So welcome. This talk is really about things that I've learned at Square since joining 4 years ago that I think really help us to build software across lots of different developers and many lines of code without imploding. It's something that I think if you're not at our size yet, though, it's stuff to think about now before you get to our size. So I wanted to share kind of what I've learned here. So today our focus is going to be on kind of four main concepts. How do we work effectively in a large code base without stepping on each other's toes, being blocked on PRs, waiting for other teams that we don't interact with much to approve our PRs, et cetera? How do we share code effectively across the organization, especially across different areas of the app where neither team that builds those areas of the app knows much about the other side? So how do we share code across those boundaries? How do we maintain a consistent architecture as we have hundreds of developers all working on the product? How do we make sure that they're all working in the ways that we feel is appropriate for our code base? And then we'll leave with some tips for tackling large refactors, which will be a short section at the end. What we won't focus on today are very fine-grained, detailed implementation specifics. One, it's too much to fit into a single talk here. Two, I don't think it's that important. I think more than the technologies we pick or exactly how we've implemented it, it's the design patterns here that are really helping us at scale. So first, just an obligatory about me slide. So I'm from Columbus, Ohio. I've been writing software for over 20 years. I think it's like 22 at this point. Graduated in 2003, so do the math. I've been at Block for 4 of those years as an Android developer, mostly in our Android platform team or foundation team, which we do a lot of things as a team. We support a lot of the frameworks that our feature engineers use across the organization. We set design standards and patterns, and we help other teams when they have questions or problems within those patterns. Before that, I've been at a few other places, Big Nerd Ranch, Rome. I did a lot of independent consulting. I do have a family, that is my dog. So why am I up here today, though? So we certainly, I won't say scaling problem, we have a lot of scale at Block. Specifically within Square where I work, we have approximately 200 engineers, all working on a single mono repo code base every day. Roughly 2 million lines of code, and if you saw my abstract, I think I typoed and put 5. It's really more like 2. But either way, I hope you're not disappointed because all these things apply. We have 5,400 Gradle modules within our code base, which before I joined Square seemed insane, but I'll explain to you why that's actually how we keep sanity. We have roughly 10 apps that we build, different flavors of our point-of-sale product that we deploy to different platforms, also other companion apps that go to some of our platforms, and all of those get built with subsets of those modules that are in that same code base. So each of our apps contain roughly 4,000 Gradle modules worth of code. Now, your team may not be at that scale, and I'm hoping not, because if you've reached that scale, you've probably reasoned into a lot of these same things. But I'm hoping if you're at a smaller scale, maybe 6 developers with 10,000 lines of code and 1 app that you're supporting, these things can be helpful for you so that as you scale up, you're going to be ready for that without imploding. So let's kind of talk more about the problem set before I get into the solutions. It doesn't happen overnight that you're a large-scale company, and it often doesn't happen when you expect it. You know, when you start out, maybe you're a 6-person team, and you have maybe a very small app with 4 sections to it. 1 person works on the login piece, 1 person works in some settings screen, maybe a couple people work on some other features. You can see orders and customers there. You know, at this point, it doesn't really matter what UI framework you choose, at least my opinion. You can choose navigation component, you can roll out your own presenters. It doesn't matter because if you need to make a change, there's no large-scale change at this point. You just talk with engineers in your small 6-person group. There's not a lot of code to change. And if somebody from the customer's team wants to make a change within settings, maybe add a new settings for their customers part of the application, they just go talk to the settings person, right? And the settings person is probably approving their PRs, right? So at this point, your code consistency, which frameworks you're using, everything is supported by a lot of crosstalk and communication. The problem is, as your application grows and you start supporting more features and things, these things start expanding, and they start expanding slowly and iteratively. Maybe your customers and your orders features break out into sub-features. You have different engineers working on those sub-features. At this point, it gets a little bit harder to use communications and PR reviews to kind of capture and make sure you're all on the same page. And this continues to grow as your organization grows, and eventually you end up with something like Square. We're certainly not unique. I know Uber, probably Pinterest, a lot of teams and people find themselves in this boat where you have lots of features scattered throughout the entire organization. Engineers on the left side probably don't even know engineers on the right side. Like, we have 200 engineers. I guarantee you there's 100 engineers that don't know me, and vice versa, right? So there has to be something that keeps us working cohesively and in a way that somebody on developing this feature all the way from the left can just quickly consume something from feature on the right. And what are these things? So I'm going to break it into two parts, architecture and processes. There's probably a lot more that I could speak about today, but I think these are kind of the three pillars on the architecture side that I think are most important and give us the biggest bang for our buck, and then I'll talk about some of our processes too. So what are those architectural pillars? Modularity, and by that I mean how do we break our code into various modules? Dependency injection, which you've heard a lot about today. I'll talk a little bit more about some specifics that I mean around dependency injection. And UI framework. And what I mean by UI framework is not a prescriptive single framework, but things to think about when choosing your UI framework. Along the way, I'll try to make a note of when I suggest, and this is just my personal opinion, but when I suggest introducing these things, whether it's very small when your application's just those 6 engineers, or as you start growing up. So let's talk about dependency injection first. I think that there's I don't want to say rumor, like there's a thought process that there's a lot of boilerplate associated with dependency injection. I think it always sounds worse than it is. There isn't too much to get started, and once you've wired up some basic dependency injection, contributing to it later becomes very easy. So I would say start this early. It's already going to benefit you on the 6-person team. And it's the only way that you're going to scale as you grow up. So this is an example of just a very trivial example that's not even injecting any dependencies, but this is how we might start to define a class within Square that uses dependency injection. A few things I want to note here. Notice that in this case, we're coding to an interface. So if you think about that module picture that I showed a few minutes ago where all these teams are working in different areas of the app, if I'm building this real checkout flow and I want to share this checkout flow with other teams, I'm always going to code to an interface. And as we go through here, you'll see why that makes so much sense for us. But basically, that interface allows us to commit to the API without actually committing to the implementation, which might change at build time for the app that we're building. Or maybe some other settings, not just the app we're building. And so in the same token, if we're depending on something outside of our module, we'll most likely depend on an interface. Again, depend on the APIs without committing, swap implementations. We actually, for us, we deploy to different platforms too, so we'll take the same app and deploy it to different platforms, which might require different implementations that satisfy, for example, a payment engine. Also, obviously, it helps with fakes and tests. The other thing that I would recommend, and people don't talk about this initially with dependency injection, is think about established scopes within your organization to put these things. So if you don't know what I mean by scopes, I mean like a bag that has a life cycle associated with it where you put bound dependency types in. So what are some examples? Like for us at Square, so first of all, I kind of glossed over, we typically have 3 main scopes, these bags that we'll put things in. And each one, as you go from the outside in, is a super scope of the other. We use Dagger subcomponents to do that today. You don't have to, but that's how we do it. And anything that we put into app scope is generally available for the lifetime of the app. We've been making some recent architectural changes that's changed that a little bit. Jacob, looking at you. But you can think of that as available for the lifetime of the app. Anything that would be dependent on the merchant that's logged into their device would go into like a logged in scope, and anything that requires UI for us would go into an activity scope. So I'm not suggesting that you do these exact scopes with their exact life cycles. What I'm suggesting is you go back to your organization when you're thinking about this and think about which makes sense for your organization. There could be a subsection of the app that necessitates another scope for your org. Okay, so what are some examples of things that we put in our app scope? So coroutine contexts are a good example. We don't want feature engineers to somehow create their own or have some bespoke way of pulling these in. So we put coroutine contexts in the app scope. Any feature in our entire organization just has to add these as, I mean, they have to have a Gradle dependency on the public API for this, but outside of that, they just declare in their constructor, hey, I need one of these, and it's guaranteed to be there, and it's guaranteed to be there at compile time. Another example where you'd use, for us, logged in scope, we have this idea of a feature flags client, which can read values of feature flags, but that's dependent on the merchant that's logged in, maybe the merchant's geolocation, et cetera. So that would come in as a logged in scope dependency. Similarly, I have an authenticated OK HTTP client that again is wired up for that logged in scope. The other thing that helps us, so this is a great way to organize, but even this starts to break down as you scale up because each of those components, at least with, each of those scopes, at least with Dagger, maps to a component, which maps to a class for that component. And that component, you know, in vanilla Dagger is pointing to modules, which are pulling together the right modules for that application. And this blows up really quick if you have a lot of applications, because each application is going to have 3 of those classes pointing to various lists of modules. Even at 2, this starts to get larger, and we have 10 apps, so this is not tenable either. So actually, before I joined, I just got to benefit from this. One of our engineers, Ralph Vanderstack, I hope I said that right, created a tool called Anvil. You might have heard of Anvil here. What it does is a lot of code generation for dependency injection. As I promised, I would kind of give you a hint of when I think to add this. I mean, it doesn't hurt to add it from the beginning, but certainly once you start breaking out into sub-feature teams, it's really helpful to have this kind of stuff, because what it allows you to do is, through annotations distributed throughout your code base, declaratively say where these things bind together. So for example, I have this real checkout flow. It's providing a binding for this checkout flow interface, putting it into the logged in scope. By the way, it's a single, and it's binding it for that type. So you'll see this throughout all of our code bases, and then what's really neat, and you'll see this when we get to the module structure, which app does this get pulled into? It really depends. So this will live in an implementation module, and it depends on which implementation modules are being pulled into which apps that pull these together. Anvil will generate all the cruft that needs to be done, the Dagger factors, et cetera, to make all this stuff work. This bleeds really well into modularization. So again, 5,400 modules. Why do we do this? Well, it gives us a very clean separation of concerns so that all of our teams, like the customers team, for example, can go off and really just focus on what they're building without worrying about what the orders folks are building or what all the other teams across Square are building. It also allows them to keep their build times low because they're depending on interfaces, not implementations, right? So that's already potentially small if you put fakes or no-ops in instead of the real implementations. And it allows us to be very flexible and swap out implementations as we build. So the interfaces typically, so for any given feature modules, you'll actually not have a module for that feature itself, but in the root of our mono repo, you'll see like a common directory, and then you'll see a directory, not a module, for that feature. And inside of that directory, you'll see a handful of modules, typically 4, sometimes there's a few others for different reasons. All of the interfaces for anything that we'll want to share or use your module go into this public module. That makes that module very small and very trivial and easy to kind of pull together. There's not a lot of compilation that goes in that module. Your implementation will go in the impl module, and that's where you'll both define the implementations and through Anvil declare which scope you contribute those into. There's a few others that we use. One's in impl robots. Think of that as like a driver for your implementation so that if you're writing a UI test, maybe another team's writing a UI test for, let's say, the customer's section. We call that an applet. So the customer's applet within our point of sale. Maybe they want to drive a settings screen, right? So settings would have an impl robots module that they can use to say, click on this setting, scroll to that setting, click OK, make those changes. And that way, they don't have to think about the implementation specifics. They just have to know that in a test, they're pulling in that robots module. And finally, a very common one is what we call a demo module. So what is that? That is an Android application module that's pulling together implementations to test this small feature in isolation. And this has lots of benefits. One of the biggest ones is, to build our point of sale with 4,000 modules, believe it or not, it takes a little bit of time. It takes, I don't know, we keep getting the best MacBooks to kind of try to keep up, but like at least 10 minutes, let's say, give or take. It used to take half an hour. But a demo module is very quick. There aren't quite so many, you're not pulling in the actual implementations that you might depend on. There's a lot of no-ops, there's a lot of fakes. And so your demo modules are quite small, and it allows those teams to build within maybe 30 seconds or a minute from a cold build. This structure also allows us to make bespoke implementations for different variants of our app. Take variant loosely, I don't mean like Android variant, but a different version of our app that we compile and build. So like maybe we have one implementation that applies to most of the products we build, but we might have a very retail-centric one for our retail developers that have a shop that are using Square. So this structure allows us to do that efficiently and wire those together appropriately at the end. So we have these modules. We also have very strict rules for what can depend on what, and that also kind of helps keep sanity and also helps us improve our build times across the code base. Like for example, if one of these we know we're never going to need to run Dagger, we don't have to turn on Dagger for, say, like public modules, etc. Impls can't depend on other impls, so if you have that impl retail situation, we usually have like an internal module that those things depend on, etc. So I've been saying this a lot with like wavy hands, but like I think this graphic hopefully captures it a bit better. So let's say I have 3 features in my organization, and I want you to focus on feature A's impl. Notice that to satisfy its job, its implementation, it has a dependency on feature B. But it doesn't really know or care what that implementation will be. It's going to depend on their public interfaces, essentially, right? And then, so if you look in the bottom corner, it's kind of hard to see, but I've shown that inside of the implementation module for feature A, we have an API project dependency on features A and B public. That's this one and this one. What happens then is when we build the point of sale app and its build.gradle file for the application, it pulls in the impls that it wants. In this case, the main impl from all 3 of these features. but we might have another app. In fact, we do. KDS stands for Kitchen Display System, but make up your own app for your organization. You could just pull in a different implementation, and feature A doesn't change at all. Doesn't really care. So I've kind of covered these a little bit. Since we're tight on time, I won't spend too much more time on it. But these two things together, dependency injection and modularization, is huge. I'd say that's kind of like the main two pillars. And then the last thing I wanted to point out is our UI framework. I recommend personally, I know there's a lot of options out there, and I think when you're at a small scale, it doesn't really matter as much, but when you get to a large scale, you really need to think about how you're going to maintain things across the ecosystem. So I personally would recommend unidirectional data flow, strong contracts, and I'll show you what I mean by that, and strong coupling between your navigation, model, and UI state. And I'm going to explain that through an example. So let's say I have a simple app. You can see the bottom navigation at the bottom. There's a customer section, there's an order section, there's a settings section. I want to focus on the customers. So let's say you hit the C in the lower left, you go to a list customers screen. It's supposed to list the customers in your organization. Maybe you don't have any customers, so there's some button you click and you navigate to the add edit customer screen. You're adding a new customer. Once you've added and saved that customer, you might go to a view. From there, you go back to list customers. From list customers, maybe you click on one of those customers, you're back to view, and you want to edit, you're back to edit. The reason I show you all this is because there's a lot of complexity in the navigation just between three screens. Now introduce another area of your app. Let's say you're creating an order. An order you want to associate with a customer. You don't want to rewrite those screens, so you leverage what you've already got and send them over to the list customers. Maybe change the title, change the behavior slightly. From there, either you'll go back to the create order, or maybe you, from list customers, clicked on add because this is a new customer. Now when you click save, you don't want to go to view customer. When you click save on add customer there, you actually want to go back to create order, and that creates another complexity in terms of where to navigate back and how to pass that data back. This starts to multiply across your org as you get more and more features, more and more sections of your app. And I want to talk about the problems with some of the alternatives, and I'm not picking on navigation. I actually really like navigation. I used to use it, but I think it's really well suited for a small to medium-sized app, and I want to explain why. So let's say I was using navigation, which has this kind of declarative navigation state that's different than your UI or model state. I might have this nav host. Notice that I'm using key value pairs for, well, I'm naming my destinations with keys. I'm happening to choose strings here. Notice that some of my destinations have an implied argument in the destination itself here with these IDs. And then, again, just using navigation as an example, let's say I wanted to go from that create order screen to the customer selection screen. I might ask my nav controller to navigate to this other screen by name, in this case a string, and then I might get my current backstack entry, grab the save state handle from that, then subscribe to some live data. Notice here I'm just passing a key for this live data and observing that as state. I'm already making assumptions about that list customer screen. I'm assuming, which I'll only know by talking to one of the developers, hoping that they captured it well in documentation, or sleuthing through their code, I'm hoping that they're putting the data in a field named selected customer. I don't know that. Thankfully, for this early example, they are. But this type of thing works really well when you're small. It does not work when you're large. I have no idea how most of our features work, but I do know about the strong contracts for input and output. So we'll look at another way to do that with workflow. Another problem with this presumably you'll have sub-nav graphs or sub-navigation across features. So here, if I had like a feature foo and a feature bar, it's presumed here that like the entry point to feature foo is A and the entry point to feature bar is E. But what if like I'm developing and specs change all the time and I feel like, oh man, like the G screen would be perfect here, linking it from the A screen. How do I do that? Well, if I'm using navigation, I will say probably deep link into G, because there's no direct way to access it, right? So I have other options. I could break the bar graph apart into two different navigation graphs within feature bar, but there's a lot of like coordination and continual change there. So I can do a deep link, but notice this deep link is going to make an assumption that G lives in bar. What if I want to move G later? Now, every path, every screen that's linked over to G will have to be updated later, right? There's also, hopefully, there's no implied state from E and F before I got to G. Navigation's not going to enforce this, right? So what's a better way? Well, I'm not here to push workflow. It's what I know. It's because it's what we use at Square. But there's certainly other frameworks out there. I've heard Circuit mentioned. I've heard some others mention. I think the pattern here is what's really powerful. First off, it's very explicit and clear what your properties are. The props end up being a data class. It's not key value pairs. You cannot mess it up. You either provide it or you don't. The output is also very clear, and every workflow is parameterized to say I only work with these props that are specific to me, and I only work with this output. And workflows work in a tree, and generally speaking, each workflow you'll create a class that subclasses this workflow class. You'll provide a render function. That render function will be called and given some state that you've defined what that state looks like. You'll get some immutable state. You will produce a rendering. That rendering will be used to create the screen that you're seeing, but it's also directly coupled to the navigation of where you're at within your app. And your UI state and model state is all driven by a single rendering. That's impossible. Well, you can work outside of your state, but you shouldn't. It's almost impossible. You have to try hard to do the wrong thing there. So your workflow produces a rendering that's mapped with some factory to produce a view. Events come back from the view. In reaction to that, you provide something called an action, which sends something to a sink, which basically, this isn't a workflow talk. I will share some great slides at the end for that. I think you could fill a whole talk. In fact, we have with folks of us at Square on workflows. But just the general idea here is that you have this iterative cycle where everything's together. Once that state changes, when the action finally is evaluated by the framework, if that results in new state, then your render function gets called again with that new state. It gives you the ability to produce a different result. It's very functional. The other thing about workflows then is that they're composable. So they take in props, they produce renderings, or they produce renderings not directly, but through rendering children. And this is how you can get that navigation from like create order. Once they click on add customer, we're in the state of adding a customer. So in that case, when we render this workflow, we'll render the child instead for how do we add a customer. And whatever its rendering is, we'll actually pass that back as our view. So in this case, we've navigated as a function. Well, navigation just becomes a function of our model state, essentially. And then if you come back to this example, these kind of guardrails or these gates just kind of fall down. So now if you want to go from A to G, it's very simple. You just pass the props and you say the workflow you want to go to. Now there's no barriers here. Across different features, A could go to F, it could go to H, it doesn't matter. And we know that there's no implicit build-up state between E and F because we're passing the only state, or it's not state, the only inputs that you could get to G are these props. And G explicitly said so. So I have an example here with our real app, two different areas. This says subscriptions. Think of it like that order example where you can add a customer to it. and it uses these last two screens for the customer entry. We have the exact same type of screens from a customer section of our application. And so these things are actually reused. And I've made a very simple example for how this looks, but so you can kind of see how it comes together. Workflows extend this workflow interface, which defines the props type that comes in, which you can see an example down below here. It's just the data class, the output that you might produce, and the rendering types that you produce. The outputs usually look something like this. It's very frequent that they're sealed classes, doesn't have to be though. And based on that, you can switch on what to do based on, for example, if the contact was, if a contact was selected or the process was canceled, etc. This is probably a lot of implementation details for a high level, but I want to skip to this slide. Basically, when we decide that we want to render choosing a customer, we have this context object that's very specific to workflow, but we just say, hey, context, please render this child. Here's the workflow. The workflow is the child here. We just injected that, by the way, on our class. And here's your props. And here's a lambda that I want to fire anytime there's output from that child. And so inside there, that output is whatever that output type was defined on the, like here, basically, this contact search output. And then inside there, we can queue up this action. So you see this action lambda. This isn't going to fire right away. This is work that we want to have fire to potentially mutate our state. The framework will take care of running that at the right time. Inside of that action, we have an implicit variable that's mutable called state, losing my pointer here, that we can decide to mutate the state if it makes sense based on what happened in the choose customer screen. So I think those are our three pillars. Those are the things that allow us to not know anything about any of the code in all these other modules, but know basically how they operate. Now, it's not easy to make all the teams do all these things. And so that's where some of these guardrails for consistency come in. So let's talk about those first. So, you know, when you have 200 engineers, but even when you have 50 engineers, 40 engineers, it starts to become hard to make sure, like you can't catch it through PR reviews that everybody's following the right standards that you've set for your organization, that they're not using APIs that you didn't expect, that they're not using those APIs in different ways than you'd expect. You can't make sure that everybody's avoiding common foot guns that you found within your organization. You can't make sure that the code's following proper hygiene, not by people. It's not going to work. We've tried a few different ways. We've established code owners for different areas of the projects, and we still have those code owners. But initially, I think a couple years ago, we had this thing where it's like, if you wanted to change something in our customer's module, they would have to sign off on your PR. The problem with that is everybody's busy all the time working on their stuff. So you get one of two things. You get a rubber stamp, which is meaningless, or you wait days or weeks and you have to tag their EM and basically beg and plead to get your freaking PR through so that you can continue with your work. It's really hard, and nobody's fault. It's just everybody's moving a million miles an hour. Documentation is never a problem at Block. We have lots of it. Nobody can discover or read it all. We have a lot, and people read a lot of it, but trust me, like that doesn't scale either. Training will probably be lost in a quarter. You'll cycle folks in and out. You'll switch them to different teams. Like, that's not going to work. So the approach that we found that has worked, we do require at least one Android engineer to sign off on your PR. It's required at least one person does. We actually have an unspoken rule that if you feel like what you're doing is a little bit fringe or like, you know, it's kind of a larger scale change, we often, like, gentle person's rule is like, oh, I'll wait till I get 2 or 3 PR approvals. But it's not required. Owning teams are notified and they're tagged on the PR, but they don't have to sign off. So instead, we lean very heavily into check style and other static lint. We don't stop with what you get out of the box. We actually have 45 different lint checks, and that continues to grow by a couple every year. It's fantastic because as soon as we make a change, deprecate a null API, go to a new, we don't want people to reintroduce regressions or go back to that old way of doing things. We add a lint rule. Now, every time somebody puts up a PR, they cannot merge that PR without satisfying that lint rule, or some cases we can kind of work around it. But it keeps everybody moving in the right direction. We also have a lot of custom module validation rules that make sure that your dependencies flow in the right direction. And we have a DSL, so it's not just about policing folks to kind of make them do the right thing, it's also making it very easy to do the right thing. And so we have a custom DI block, or I'm sorry, not DI block, DSL block within our build.gradle files that allows you to declaratively do common things. Like for example, you want to write unit tests for your module, hopefully. You come in here and say unit test enabled. And that's automatically going to pull in the right APIs for unit testing. By the way, it's going to fail your build when you put up the PR if you have no unit tests in your project. If you want mocking enabled, you add that as a separate thing. And that way we can control, we don't pull in the mocking APIs if you're not going to use them. And it allows developers to not think about which mocking APIs they're going to use. Am I going to use mock or mockito, like mock-k or whatever? They're just enabling mocking. So you can kind of go outside of the norm, but it's very hard to. And we have this joke on our foundation team, like we call this the pit of success. I don't know if we created it or not, but I think it's like perfect. It's not impossible to go rogue and go bespoke. It's just really, really hard. You know, you have to update some rules somewhere, you have to talk with these other teams. It's very easy to just fall into this pit of success and do the thing that we think is the right thing. I'm going to skip that because I know I'm getting close on time, which is just the summary of when you would do this. Okay, the last thing I'll leave you with is approaching refactoring. I've made it sound like Square is awesome, and I feel we are. I'm biased. I've been there 4 years, love it. I've been working in software for 22 years, and this is probably the longest I've stayed as a full-time employee somewhere. I really do love it. We really do have tech debt, okay? We're not perfect. We have lots of tech debt. Well, let me rephrase that. We have lots of, the appropriate amount of tech debt that you would think you would see at a large-scale organization. We won't let you down there. How do we approach it? We found two different ways to, we think of this in two different ways, and we didn't coin this specifically. I think one of the cache engineers, Jesse Wilson, did. There's a really great article that I feel like describes my life. I would check it out later here. But their idea is farm versus grind. So let's talk about the two to understand the differences. By the way, I think I'm about up on time. Do you all have like 3 or 4 more minutes? Yeah? Okay. Then I won't feel like I have to rush. Thank you. So grind. A good example of grind, well, let me step back. So what grind is the idea that there are some refactors across your code base that you don't need those other teams. Like you might be refactoring other teams' code, but you don't need them to be involved with that. You'll probably give them a heads up that, hey, I'm going to make these changes, this is why, et cetera. But then you can go out and make those changes yourself. And things that can be easily regex or scripted or I guess now agentized with AI or whatever, those are like really great candidates for it. So I'll give you an example. About 2 years ago, we decided we had been working on moving to a different logging framework. We were using Timber before. We went to a new framework. There was still something like 2,000 or 3,000 call sites with slight variant usages of the Timber API. I was able to go there through a series of scripts and regexes that I wrote, basically transition everything that was left over to the new thing. And I added lint rules to make sure that there were no regressions in there. That was a great example of a grind approach. It helped the organization, but nobody else had to get involved. The other type of approach is a farm approach. And this is more helpful if you're in a situation where making these changes is not mechanical. There's a lot of business logic decisions to be made, and it really requires the domain expertise of that team. In this case, you need to think about farming this out, and it becomes a different way of getting this work done. First, you have to show some PRs for what's the alternative, and this thing called a runbook we typically would create. And what that is basically first like a quick blurb of, hey, this is where we're moving to, and this is why it's really important for you. Maybe it saves your team time, maybe it's more efficient, et cetera. And here's how you do it. Here's a few example PRs. Here's stepwise, kind of like the framework of how you do it. Here's how you can validate that you did it successfully. And then from there, we'll create JIRAs or other tools that we have internally to create a burn down to see which teams have done it and which teams haven't. I can tell you from experience, this works sometimes, or maybe it works sometimes to 80%, then that last remaining 20% is really hard. But if you can't grind it out, it's your only alternative. The reason that it doesn't always work is not just because the team doesn't want to do it, but again, they're working on their own stuff, and oftentimes there's some complexities that require even careful thought from their side, so it just takes time. And then finally, this is the last content slide. Finally, there's a combination effort, and we've done this a few times. Last year, or a year and a half ago, we had this massive effort to take 6 of our point-of-sale apps and push them into a single application. We basically spun up many teams across the organization, like tiger squads, to do different parts of that. And then you get kind of a combination of some of it is grind and some of it is farming out to their constituent teams. So that's all I got for content. I want to point to a couple resources before I close out. So as I promised, Workflow, the GitHub open source project, is here. Ray, who's in the audience here, has spoken about it, I think at one of these 2 YouTube links, maybe both of them. I would check those out. You get a much better in-depth look at it, also because he wrote most of it. Dependency injection, if you're interested more in Anvil, I would check out Ralph's talk here. Metro's gotten a lot of press. It seems up and coming and very promising, so you might check out that as an alternative to Dagger and Anvil entirely. And if you liked what you saw, but you thought, oh, this seems like a lot of work to get started, well, the guy who created Anvil and then went to Amazon also created an open source project called App Platform, which does a lot of these basic things for you, like has a opinionated approach to get started quickly with dependency injection and scopes, manage your module structure, the robots piece, enforcement even. So a lot of this stuff, hopefully we get springboarded with this App Platform. Full disclaimer, I haven't tried it though yet. And then last thing, we didn't talk about continuous integration, but we have an entire team that's dedicated to that, and they do an amazing job. Even though our PRs do take 20 to 30 minutes to get through to a green, it could take a lot longer. We have 14,000 UI tests that potentially could run with every PR, and we have an entire team that's done an amazing job parallelizing that massively. There's a YouTube link to one of their talks at one of the Gradle conferences. With that, thank you so much for coming. Sorry we went long.